Introduction to blockchain. Today is hopefully going to be hopefully not too confusing, but also not too in-depth so that I don't scare anybody off. If there's enough interest, we can do a follow-up workshop about some more of the cryptography that goes into blockchain. But this is just a basic introduction to what goes on blockchain. Stonks. So what is blockchain? At its very basic level, blockchain is a type of distributed database. Stonks. Blockchain is a type of distributed database. So users on the blockchain network all have access to a type of distributed ledger. So it's a single shared ledger that's that all network participants can access, and it's basically just keeps records of transactions that occur on the network. These transactions, you might be familiar with cryptocurrency. That's a common application of blockchain, but these transactions can really be any sort of transfer of goods. It could, or other applications as well. All with a focus on maintaining validity of the transactions and the users, and maintaining security within the network while avoiding a centralized entity which would be monitoring these records. So blockchain was first sort of envisioned by two programmers, Haber and Stornetta, in the 90s. And it was designed to serve as a secured but decentralized type of database. So one of the most important features of blockchain is that the records of transactions that it keeps are immutable, meaning that participants on the network can't modify a transaction once it's been recorded on this shared ledger. And since it's a shared ledger, transactions are only recorded once. And this means that even if there's an error in a transaction, it's then later corrected in a new transaction, and both the error and the correction are kept on the ledger. And a piece of technology that's often coupled with a blockchain network that allows for this to be decentralized without a middleman keeping track of the records. Blockchain networks often employ smart contracts, which are very basic programs that use if-then statements to enforce these predetermined conditions. And these are rules that govern transactions. It can be something like the way that data is formatted. It could be conditions that have to be met, such as a network participant has to send funds to a specific party in order for the transaction to be valid, or they have to register a vehicle for it to be valid. So when creating the framework for a blockchain network participants will decide these predetermined conditions and then agree to follow these conditions in order to maintain the integrity of the blockchain network. And so these smart contracts then govern the... What? I'm sorry, is there a question? Okay, so the smart contract just basically automates the blockchain network and allows participants to define rules that are followed. And of course, if you have any questions, best place to put them is in the workshop channel. I'll try and keep an eye on that and answer them as they go, or just, I guess, unmute and interrupt me at any time. So how does blockchain work on the inside? So because blockchain network is this shared database, it has to handle multiple transactions between multiple different senders and recipients, often all at the same time. And so as transactions are created, they are considered pending, and they are gathered into, they're sort of compiled into groups, which are known as blocks, and they're stored with a timestamp so that all of these transactions are stored in chronological order. So as if you have a question, please just put it in the workshop channel. Thank you. So as these transactions occur, they are filled into a block, basically data structure. And then once the storage capacity of the block is filled, then that block is chained to the previous block in the blockchain. And the storage capacity is dependent on that specific blockchain network. It's often determined by the smart contract of that network, so it can vary. So these transactions between users are secured with different cryptography practices in order to maintain the integrity and confidentiality of these transactions. So in order to sort of, I guess, visualize why this is important, let's take the example of Bitcoin, which I will talk more about Bitcoin in a few minutes. But Bitcoin is just a form of cryptocurrency. So dealing with digital currency is different from physical currency. Digital money versus cash or something like that. In the physical world, if you run out of money, then you have to exchange goods or services in order to get more money. You can't just print more money. That would not be great for the economy, unfortunately. But in the digital world, a digital currency is nothing more than a binary file at its very basic level. And it's a lot easier to manipulate files. Most of us here are probably comp sci majors. I know you all know how to copy and paste. So if you have a digital wallet with a digital coin in it, how do you know that a transaction made with this digital coin is the only copy of that coin and it's not just been duplicated? And how do you avoid users double spending, which means to spend the same money at different transactions, without using the centralized authority overseeing these transactions? So the main characteristics of blockchain are that it is immutable. The cryptography applied to transactions encrypts these messages so that it's impossible to change these messages without it being apparent that it's been tampered with. It's also unhackable, meaning that you can't change a message without, you can't change a transaction without causing without completely changing all of the previous transactions that have occurred, because they're all chained in and encrypted in a way that keeps them chained, and it's also a persistent data structure, meaning that there's no loss of data. Again, like I said, all the transactions that have happened on the network, these records are kept, and you can't delete or modify these records. Even if there's an error, the modification is made and appended to the blockchain with the error. And obviously, also, blockchain is a distributed system, meaning that it's shared. All network users have access to the same records at the same time. Are there any questions so far about blockchain and how that works? It's I know it's a little hard to visualize, but I've got a couple of pictures if you'd like to see those. All right, I will keep going. Feel free to post questions in the workshop channel. So the biggest issue with blockchain is how do we validate users' identities and avoid sus transactions, right? So one of the cryptography methods that is applied in blockchain is a public key infrastructure, also known as PKI. And basically, within a public key infrastructure, there are pairs of public and private keys that are encoded with a signature verification algorithm. You can kind of think of a public key like a username, which is used to identify, which is public knowledge, and it's used to identify a network user to other network users. And then the private key is kind of like a password. You can sort of think of it like the password to your bank account or the PIN to your debit card. You shouldn't share that private key. And if you lose the key, then you put all of the assets in your digital wallet at risk of being stolen. The signature verification algorithm is sort of like a function for the public key infrastructure. For example, say person A wants to send a private message to person B. Person A is going to send this message with person B's public key, and they're going to encrypt their message using the signature, using this algorithm. And then once person B receives this message with their public key, then they have to use their private key in order to decrypt the message that has been sent by person A. And so that not only validates that because person B is the only person with the private key for then that verifies that the person who receives it is person B, and it basically just establishes trust in the transactions by authentifying or by verifying the identity of both person A and person B, and also for message security, how it's private until it's decoded. And the private key is basically just mathematical proof that the transaction came from the owner of the assets.
I have a quick question.
Yeah, of course.
Okay. So I always kind of get confused about this when I talk about it, about all like the private and public keys. I just want to get this straight. So when a sender, say like I'm the person who's sending that I've done maybe a transaction like you were talking about. So do I encrypt that message with my public key and then I send it to whoever is supposed to decrypt it? And do they decrypt it with their private key? So like in a way, anybody can encrypt, but only a person can decrypt, or do I have that totally wrong?
Yeah, so that's I mean, that's just one. I think you're right. So that's just one way that public key infrastructure is implemented. And so basically, and this will make a little more sense once I cover hashing. But at its very basic, the message is encrypted, and the person who receives it has to use their private key to decrypt it. And so the private key is private only to the person receiving it. But the public key is used to decrypt or to encrypt the message with the signature verification algorithm. So because the two keys are paired, that's how they're able to decrypt the message only by knowing the public key or the private key. Does that
Okay.
make sense?
Yeah, I think so. All right, thank you.
Yeah, of course. So I uh, here I have something for workshop participants today that I definitely did not spend time working on today. Um, but anyways, all right, moving on. Just a little meme. All right, so now I'm going to cover hashing, which is how these blocks are encrypted and how we're able to verify that these transactions happened in chronological order and that they haven't been tampered with. So, very, very important concept. A hash function is a one-way algorithm that maps data of any size. So, it can be, any sort of message. You could encrypt like a textbook-sized PDF to a bit array of a fixed size, which is also known as the hash. So, because it's a one-way algorithm, um, once you convert your message to the hash, it's practically impossible to determine the message given the hash. So the hash function, um, uh, so once you have encrypted the message using the hash function and you receive the hash, it's basically just a string of a bit array of a fixed size. So it just looks like a string of random numbers and letters. And so even if you changed the original message by something as little as a single letter or adding a period or an exclamation point, say, that hash function changes entirely. It's not like it's not like a math function where if you say 2 plus 2 is 4 and then you change it to say 2 plus 3 it's 5. It's it's not like the it's completely encrypted basically. I hope that makes enough sense. And so this sort of gives a little diagram of what these what a blockchain structure looks like. So here we've got a list of transactions that have happened that have been collected by a blockchain or by a miner who is mining these blockchain. And I'll talk about how we mine Bitcoin in just a second. But these are all pending transactions here that have been collected. And once we reach the storage capacity for the block, then each of these transactions is encrypted with the hash function. And then as a whole, this entire block is then encrypted into a hash function. And so now, after that block is created and it's added to the chain, or maybe this is the first block in the chain, the next block starts being filled with these pending transactions. And then once this block is made, then we can consider these transactions to be approved, meaning that they were verified by the miner that these happened in chronological order and that the funds that were used in the transaction are valid. And so we've got this first block in the chain, and this next block in the chain has these transactions as well, which are all encrypted with the hash function. But then as a whole, this resulting hash function is going to be calculated using the hash functions from all of these transactions, as well as the hash of the previous block. So each one of these transactions, if you were to try to change just any one of these records, it would completely change the resulting hash. So it would be impossible because each one of these transactions relies on the resulting hash for each of the transactions relies on the hash for the previous transaction or block. So everything is in chronological order, and it's impossible to change the hash for any single transaction without completely changing every single hash that came before it. So impossible. So then that just continues, and then the resulting hash function is then used to calculate is then used for the hash for the next block, and then thus we have created this chain here. Does that sort of make sense? Of course, if there are any questions, feel free to say something, or to respectfully say something, or to put it in the workshop channel. All right. So to further illustrate blockchain, I'm going to introduce one of its applications, which is Bitcoin. I'm sure everyone here has heard of Bitcoin. It is a cryptocurrency which utilizes blockchain as the technology to verify these transactions and the identity of users. And this was first proposed by Satoshi Nakamoto in the white paper, which a white paper is basically just like a less formal research paper called Bitcoin, a peer-to-peer electronic cash system. It was released in 2008. And in January of 2009, Bitcoin was released as an open source software. And this is the first major application of blockchain. Now remember, blockchain was first introduced by our programming friends, whose paper and Jornetta in 91. So this is nearly 20 years later that it's first utilized. But Bitcoin was intended to decentralize currency, meaning that it would make it more accessible to the users and also less expensive, because if you have a centralized bank that you're having the banks verify transactions and keep track of funds, banks are also going to add fees and add time to transactions. So Bitcoin was developed to sort of decentralize currency and put it back into the hands of the users. So one Bitcoin currently is worth a little over $36,000, and the smallest denomination in the Bitcoin network is known as a Satoshi, and one Satoshi is equivalent to 1 times 10 to the negative 8th Bitcoins. So it's a very, very small amount. So again, some facts about Bitcoin is that it's a decentralized currency, meaning that there's no centralized authority. Because blockchain is it's a distributed ledger, all of the users on the network work together to kind of in order to eliminate that centralized authority. And they're just like how you can't go printing more money without causing problems. There's also Nakamoto proposed a limit of 21 million Bitcoin in circulation. And now, as of January 2022, there are currently 18.9 million mined Bitcoin. And I'll talk about Bitcoin mining in just a second here. Fun fact for you, Nakamoto is actually a pseudonym, and the person or group of people behind Bitcoin remain anonymous to this day. I believe no one has stepped forward to claim ownership of the Bitcoin system, and it is open source software as well. And I think this is an even more fun fact. The first known commercial or physical Bitcoin transaction actually occurred in 2010 when a California programmer sent a message to some random Florida college student, and he sent him 10,000 Bitcoin and asked him to order 2 random Papa John's pizzas to be delivered to his house. And in 2010, 10,000 Bitcoin was worth $41. And as of 2021, it was worth $365 million. But I read an interesting article about that, and the programmer who ordered who wanted the pizzas to be sent does not regret his purchase. And like I said, there's a limit of 21 million Bitcoin in circulation. The total number of Bitcoin isn't expected to actually reach 21 million because the Bitcoin network actually uses bit shift operators to round down in fractions of Satoshis. So 21 million is just the hard cap, but it's not likely to ever actually reach 21 million Bitcoin. I agree, Papa John's is not that good. All right. So, what is Bitcoin mining? I think there's actually a mod for Minecraft where you can mine Bitcoin, but I don't actually know that much about it, so I can't speak to it. I just think this picture is funny. All right. So what is Bitcoin mining? Bitcoin mining is one way of producing new Bitcoins by solving hash functions in order to verify transactions in the currency. So Bitcoin, roughly one Bitcoin is mined every 10 minutes. And that number that 1 in every 10 minutes is regulated by something known as proof of work, or a nonce, NONCE. This is a reward. It's like a reward for these Bitcoin miners for successfully verifying a block and adding it to the chain. And so once they can prove that the transactions that have been collected, that the pending transactions collected in the block, that once it's verified that the transactions are valid, then the block is added to the chain, and then the miner is paid a set amount of Bitcoin. So for every roughly every 4 years, the reward for a mined Bitcoin is halved. However, the price of Bitcoin is volatile. Like I said, in 2010, it was worth, like 10,000 Bitcoin was worth $41, and then now it's worth 365 million. So miners don't really know what their payment is going to be worth until they receive it. So the main idea to remember with Bitcoin mining is that the blockchain is a distributed or a shared ledger, meaning that every time a transaction is requested, everyone on the network can see the request. So miners are verified network users who run software for mining these or collecting these Bitcoin transaction messages. And multiple messages come in from multiple places at any given time. And so the miner will collect these messages as they're received, which remember they are time-stamped and in chronological order. He'll collect them into a single block, and then the miner creates the hash for the block using the hashing function, which is unique and would be changed if the contents of the block were modified. But Bitcoin mining is definitely not easy. For anyone who's tried to build a PC in the last couple of years, you might have noticed an extreme spike in in GPU prices and availability, and that's because as Bitcoin mining kind of evolved, people went from using just regular CPUs to building bigger mining rigs with GPUs, because when it comes down to mining, it's not so much I described it as solving hash functions to verify these transactions, but it's not really like solving a mathematical equation. It's a bit more like trying to guess the lottery through brute force. Because remember, the hash functions applied to these transactions make it nearly impossible to guess the message that was sent given the hash. So these miners use really powerful technology to basically guess the lottery. And so the sort of severity of the hash function encryption is adjusted so that it's the how difficult it is to successfully mine the Bitcoin is adjusted, like I said, so that one block is roughly added every 10 minutes. So again, mining just involves solving hash functions through brute force. It's really, really hard to do in reverse, but once it's done, it's easy to verify. And I actually have a pretty good example of this. So it's a very miners can have a little Bitcoin as a treat. So okay, when you this is a very it's not really a solid or okay, this is a very watered down example of how verifying hash functions works. So say I've solved a super complicated math problem and I want to send it to my friend Dan Yi, and I want to see if he can solve it, and I want to prove that I've solved this math equation without giving him the answer. And so I am going to send him the math problem, and then I'm going to encrypt my answer using the hash function and send him my hash, which again is just like a random bit array that looks like a string of random numbers and letters. And so Dan is going to solve the problem, and then once he's got a solution, he can then decrypt he can then encrypt his answer using the same hash function. And then if his resulting hash matches mine perfectly, then he knows that he got the same answer that I did without necessarily seeing the actual answer. And so in this case, it's an analogy where my funds have this hash function applied so that it's a unique identifier for my currency, and I'm proving that I own this money and that it's the only copy of the money. So it's easy to verify that that two hashes match, but it's incredibly hard to sort of reverse engineer a message given a hash function because they are one-way functions. That was a mouthful. Does anybody have any questions about Bitcoin mining? I really tried to break it down here, but it's basically, it just takes a lot of computer power to try and verify these transactions, and then Bitcoin miners are given a little Bitcoin as a reward.
This
Um,
isn't so much a question, but something like a little tidbit about blockchain and specifically Bitcoin. So like with Bitcoin mining, there's kind of this idea almost of like a collision where it's like if like these people are mining like all the time and trying to compete like who can get the next block on the blockchain, but like each block it's just going to consist of like a certain number of like valid transactions. So it's probably not going to have all of them. So you can run into the case of like having two blocks like put onto the blockchain like right next to each other. So what they do is like for Bitcoin at least, they go with the longest block and they go on that chain. So you have some chains that are like almost like careening off of like making new kind of like length one little branches, which is pretty interesting.
that is pretty cool. I can't say that I know too much about Bitcoin mining, but yeah, I do remember reading that because all these transactions are happening at once. Once a block is added to the blockchain, then miners have to go in and make sure that that they're not adding the same transaction to the chain that was then approved on the most recent block. Um, but yeah, thank you for that tidbit. I'm that's pretty interesting actually. All right, so blockchain has more applications than just cryptocurrency. It's also used in the food industry. It's used to track food origins and sort of control contamination and sort of pinpoint where that's from. So sometimes you might see like, oh, don't eat your kale if it came from California because it's got E. coli or whatever. So that's helpful for the food industry. It's also used, it's got other applications in banking and stock markets for securing these transactions and verifying identity. It's also used in healthcare to protect digital medical records, and it's also used for um, verifying, digital signatures so that you can access your medical records online. And it also controls. It gives users a way of limiting access to these private medical records because you're using this the public key infrastructure to basically prove your identity. And like I said, these transactions that occur on blockchain networks um, aren't just you know currency. It can also be assets like houses. Blockchain can be used for land disputes to prove ownership, and it can also be used for voting. I know there was a U.S. state that is looking to implement blockchain to verify election results as well. So obviously, as with any technology, there are pros and cons. Blockchain is sort of on a hot topic for its incredibly secure or very very secure way of verifying hot topic, yeah, of verifying identity and keeping and verifying, funds in the case of cryptocurrency. It's good for decentralization and also traceability, transparency, in that all of the network users can access all of these records. Um, it's open source software, and that you can easily see every single transaction and easily verify whether that is a valid transaction or if it's been tampered with, and also for faster transactions by cutting out the middleman in that case. But there are also cons for blockchain. I kind of skipped over this point, but for if you're looking to get into Bitcoin mining, the software itself is free. Making an account to get your digital wallet for collecting Bitcoin is free, but mining is incredibly taxing on the environment. Studies show that a single Bitcoin transaction takes 1,544 kilowatts per hour, which is equivalent to 53 days of power for the average US household. Some countries already have enforced restrictions on mining and trading. I know I read that, I believe in Malaysia, they had some public demonstration, well, not demonstrations, but they were publicly destroying mining rigs. The government was. I believe in China, I believe they've outright banned mining and trading. And I know Tesla has also stopped allowing Bitcoin purchases, or as currency for purchasing your fancy cars. So it's got a very large energy consumption. It also has a bit of a redundant performance. So every time the block is added, all miners have to update their ledger and check that they aren't adding an already approved transaction. So it's also blockchain is also costly to mine. I know the method that I described is just one way of mining Bitcoin and adding blocks to the chain. There are other there's research being done to develop other ways to mine Bitcoin, but ultimately it's very costly to host these mining rigs and pay for the electricity bills. So, and there are also very complex verification processes involved. The cryptocurrency, or sorry, the cryptography methods that I covered only really scratch the surface of all the different encryptions that are applied to blockchain networks, so that can sort of complicate transactions. Another con is integration. So blockchain would replace legacy networks for enterprises. So this is more a con for a business like enterprise. But blockchain can't work alongside legacy networks, so companies would have to completely ditch their legacy networks for blockchain. And so there's some uncertainty there. And then also uncertain regulations within cryptocurrency can lead to scams. There is currently no regulation regarding cryptocurrency, so governments also struggle to adopt blockchain technology. Are there any other questions about blockchain or Bitcoin? Again, this is a very very introductory look at the technology, but certainly if there are any questions, I'll do my best to answer them as well. And again, if there's enough interest, we can certainly do a second part workshop where we do look more into the cryptography that goes into blockchain. It's actually pretty interesting. I'm not gonna lie. Okay, so as long as there aren't any other questions, we can move on to, and of course, feel free to drop a question in the workshop chat as well if you think of something later. So let's build a basic blockchain with Python. I think that'd be fun. So I have a link here for a website that outlines how to make a basic blockchain network, including code for mining blockchain. We're just going to do a very basic data structure for blockchain that will help you sort of visualize what goes into, what kind of information is tied to transactions and how that works. Yeah, and we're using Python. It is a very popular language in data science, and yeah, so hopefully it will be easy enough. So I know the in the wonderful notifications you get from our my fellow officers, that if you guys have Python and you have an IDE, you can work alongside me. If not, I'll make one from scratch, and you can just watch and learn. There's also some source. So, all right, let me pull up my IDE so that we can make a blockchain. Let me just change my screen here. Really? There aren't any questions? You don't want to pick my brain? I forgot to mention it, but a common example of public key infrastructure is that you might have heard of is SSL certificates, which basically just verify. It's used in networking to verify website hosts. So you might have heard of that. That's an example of PKI.
How does blockchain deal with packet loss? Out of curiosity.
I have absolutely no idea. I apologize. That's a great question. That is a great question. I am not well versed on networking, unfortunately.
That is fair.
That is a great question. I will look into that, and I will I'll post the answer in the workshop chat. Yes, Dan, you did miss all the memes.
I also have a question, if I'm allowed to ask.
Yes, of course.
Okay, so something that kind of puzzles me is why does blockchain mining use GPUs instead of CPUs? Why do they use like graphical processing power? instead of normal processing power?
That is another great question. So by chaining GPUs, it because ultimately we're just brute force guessing these hash functions. I think it just comes down to more power behind the component versus CPUs. I mean, people used to just run mining on a single CPU on their computer. Yeah. So actually, I remember from when we I don't know if anybody else here was in the KDD Cup that we did a few months ago. We finally got to use the college's fancy GPU.
The supercomputer! I love that
Yeah,
thing.
finally.
I just
Yeah.
want to say fuck
You
the
just-
ITS. That
You
is
just
all.
broke my ears, James. That was a good-
It was worth it for the supercomputer, right? Anyway,
Yes.
yeah, GPU's good. GPUs, it's all about parallel algorithms are way faster. When you have like all of those cores, you can get some insane speed ups. It's all about Amdahl's law. Also, I think technically these are randomized algorithms as well, since basically you're just doing a ton of hashes. It makes it way faster to use GPUs than CPUs. Whereas a CPU can probably do like maybe, I mean, you're limited by clock cycle, right? So you're going to be able to do, let's say if you can do like 10 hashes per second on a CPU, there's like a gazillion cores on GPUs. I think we're up to like 4,000 something CUDA cores per GPU on these NVIDIA ones, or maybe even past that now. But you can get some insane, so you can get like a 4,000 times speed up by doing these low level operations on GPU hardware instead. And then if you want to be even faster, they design application-specific integrated circuits, which is literally like a hardware circuit designed explicitly to mine Bitcoin, and that's what all like the pros are using. If they don't want to pay for a gazillion GPUs. All right, I will stop talking now.
Thank you for that additional information. Does that sort of answer your question?
They yeeted.
Awesome. All right. Well, yeah. Thank you for that insight as well, James. So, let's get started. Let's make a blockchain, guys. Isn't this exciting? I'm excited.
I'm very excited.
Oh yes. And it's, what's even better is that it is possible to make it in less than 60 lines. I mean, of course, it's not very certainly it's not complete at all, but in its most basic form, the blockchain, we can make that. Awesome. So, I don't know if anybody's actually following along, but I will sort of explain what we're doing as we go, so that you can sort of understand. All right. So we've got our Python file here as well. So we're going to make 3 import statements. We're going to import hashlib for our encryption. We are going to import JSON, which is going to be how we store the information for each transaction, and put it into a format that can be read easily. And then we are also going to import time from time. Yep, excellent. Just kidding, we don't have to worry about that. Okay. All right. So first here we are going to define our blockchain class. All right, first we are going to create a constructor for the blockchain. So it's going to have a couple of variables. First, we are going to define just an empty array called the chain. We are also going to have an empty array for pending transactions. And now, if you remember from my description of the blockchain, as in the process of mining a new block for the blockchain, these transactions are collected into a single block. Sorry, the object is the root object class. I think so.
That's interesting. I've never seen anyone inherit from object. Like, this feels like if I was in Java, I'd be doing extends object, which is done implicitly if you don't extend anything else.
Yeah.
So I'm like, what is this? Do you have to extend out? Do you have to like inherit from object? This is interesting.
I don't think so. But the whole example is sort of created with object-oriented programming in mind. So I'm going to throw that in there anyways. So
yeah, it doesn't make a difference other than being more explicit with it.
Yeah. Okay. All right. So we've got our array for the chain of blocks and also our list for pending transactions. We'll append them to this and then add them to a new block. And now we are also going to create a new block. So this is new block, LOL. New block. I can't type tonight. Okay. So this is going to be a method that we're going to define in a little bit. And we're going to use it to add each block to the chain. So for this example, we're just going to create a previous hash. And so the first block in a blockchain is also known as the genesis block. So we're just going to create a funky little genesis block for our blockchain. So the first message added by Satoshi to the Bitcoin Genesis block was actually a headline from the Times from in January of 2009. And the headline read, "Chancellor on brink of second bailout for banks." So that's actually a little fitting if you think about how Bitcoin was developed to decentralize a form of currency. Yes, thank you. So yeah, I guess you don't have to inherit from implicitly from the object class, but you can if you want to, I guess. So for this Genesis block, we can just add in a string of information. IEEE at Albany. And then let's just give it a date for the transaction, which today's a fun date, 2/2/22. And then just a funky little message. Hello world. That's a good one. Classic. And then we're also going to include our proof of work. So this is I'll talk about that some more in a little bit, but it's just pretty much going to be an arbitrary variable in this example, since we're not. It's a very, very basic blockchain. Okay, so this is our basic. This is our constructor for our blockchain class. All right, so now we are going to define our new block method. And it's going to have a couple parameters. Okay. So we're going to add a block variable, which describes a JSON object with a couple of different properties. So let's add a variable, or let's add an index for this that we're going to use to reference an individual block within the chain. So it's going to be the length of the chain plus 1, so that the Genesis block has an index of 1, which is kind of, it's really all dependent on the blockchain implementation. That's just one way to do it, I guess. And then we're also going to include a timestamp for our transaction, and we're going to get that by taking the time that the block is created. And next, we are going to add information for the transactions. And this is going to be the pending transactions list for the blockchain. So that's going to include all of the transactions that are pending when the block is created. And then this is the proof. And again, this is about the proof of work, which is just the verification of that comes from a person who's mining Bitcoin who thinks that they found valid proof for proof of work for the validity of the transactions. Again, it's arbitrary for this. It could really be any sort of string or number. In this case, it's arbitrary. And then we are also going to add information about the previous hash in the blockchain. And so in this case, it will be the previous hash or self.hash the basically it just refers to the to a hashed version of the most recent approved block on the chain. Okay. So every new block will contain these properties, but we still need to add this to the chain. So once we've so we've got this information, and now we're going to add some more lines to once we append the pending transactions to the new block, we're going to clear the list of pending transactions and we are going to add this new block onto our blockchain, and then we're just going to return the block. Okay. I'm just trying to also monitor the workshop chat, just make sure that nobody has any questions. All right. Okay. So now we're going to write some functions to create new transactions and to also get the last block in the chain for creating the hash function for the new transaction. Because remember, the previous block hash is then chained to the new block hash. Awesome. So we're going to add a property. We are going to define the last block as self.chain at index -1. So that's going to be the most recently approved most recently approved block in the chain. And then we're also going to define a function for creating a new transaction. So it's going to take in some parameters here. The sender is the person initiating the transaction, and the recipient obviously is receiving the whatever, whether it's like assets or money, and the amount is going to refer to the amount of money that they're sending. Okay. So we are also going to create a JSON object for the transaction. So we're just going to define sender with these with the parameters. And then we are going to append this new transaction, the JSON object representing the transaction. We're going to append it to the list of pending transactions. And then we're just going to return. Does anybody have any questions? I know, I think I saw a poll for who's actually following along. Sorry to be having all the fun here by myself, but that's okay. Hopefully this at least is a fun little.
I have a question quick.
Yeah.
So we have the chain as a property up in, or I guess a member in the constructor. So the chain is just containing blocks, and a block is just that kind of dictionary that we had. Oh, okay, yeah, it's a dictionary we had defined earlier. Okay, I kind of answered my own question. Sorry.
No, you're good. You're good.
Yeah, all right.
Yeah, of course. And Dan, I don't know what but yeah, I pretty much went out and bought a headset because I have so much love for the IEEE and our workshops that I wanted to make sure y'all could hear me loud and clear. So I'm assuming that's what means. All right. Moving forward. Okay. All right. So obviously, this is just a record of the transaction, who's sending it, and how much they're sending. This is a super oversimplified transaction, and it's not. It doesn't really reflect what you'd find in a true cryptocurrency, but it's representative. So, for future reference, we're just returning the index of the block, which our new transaction is going to be added to. All right. Now time for the good stuff, the juicy deets. We're going to define our hash function, which is the cryptocurrency, cryptography, which is a cryptography. We're going to be encrypting our block. All right, let's keep plugging and chugging. All right, so we're going to use the JSON object that we created up here for our block with all of this information here. We are going to encrypt it, and we're going to actually use a specific hash a hash function known as SHA-256, and that's one algorithm used in blockchain, or in Bitcoin specifically, I should say. So we are going to get dumps. There we go. We are going to turn our JSON, or we're going to turn our object into the JSON formatted string. We're just going to say sort keys true as well. And then we are going to encode our object here. All right. Now, for using the hash lib that we imported earlier, first we create, we get the raw hash by applying the SHA-256 method for encryption. And then we are going to return the hex version of it. Which we can do with the hex. Then we're just going to return the hex hash. And so that's going to be the resulting hash from the block and all of its transactions. All right. So this is our blockchain and how we can create blocks to be added to the blockchain. Now, just to sort of demonstrate how we would add new create blockchain for our with our blockchain object, would look a little something like this. We're going to create a blockchain object, and then say just create some random transactions. So new transaction. And then I'm going to send some crypto. It doesn't like. All right, I'm going to send some money to Dan, our fearless leader. I'm going to send you 5 Bitcoin, which would not be validated because I have absolutely no Bitcoin. Actually, I'm just going to copy I'm lazy to type all that out again. Let's make a second transaction. And now let's say Dan is going to send money to Dawn, who's not with us right now, but that's okay. He's going to get some money. Dan is going to send 3 Bitcoin to Dawn. And then Dawn is going to send coin to James. Let's say 2 Bitcoin. And then, so we've got some transactions here. And then we would just say blockchain new block. We're going to just give it a random proof of work because it's arbitrary in our example. And then, of course, we can repeat this. This basically just creates the block for the blockchain. And because it's in JSON, it will print very nicely, and then you can see a bunch of transactions. All right, so does anybody, isn't this cool? We made a blockchain. That's very fun. Does
Just
this,
a yay thing. At the bottom, I think we forgot to put a final the new block, the last line. Should we put a string for the previous hash, or do we not put something?
it is initialized as none.
Oh, okay, gotcha.
Yeah, but
This is the first. Okay.
Yeah, of course, but we could we could add a previous hash. This is just our Genesis block here. Yeah, so this is a very, very watered down blockchain example. I will post this example in the workshop chat if anybody wants to run it. I've also included I'll also include the link for the website in case anybody wants to try a similar example or to I believe it also includes ways that you can take it further, including implementing basic mining for your Bitcoin as well. So do we have any questions, comments, concerns, fun facts?
So what I've gotten out of everything tonight is that the blockchain is just a giant linked list, and you can't remove things from it.
Yes. Thank you for summing up the last hour and 25 minutes into 2 sentences.
Very cool. Thank you.
Yeah. So I mean, this this is pretty interesting actually. I was a little skeptical of blockchain before doing this presentation. But I think the whole cryptocurrency and the way that each transaction is it's a circle of life with blockchain. It's all connected. And it's very easy to tell when people are falsifying records. So don't pay your taxes, kids. No. Don't cheat on your blockchain because you will not make it very far. So yeah, I'd love feedback if anybody. Yes. Let me give you the link for the website, of course. if you've got any feedback, feel free to let us know. Again, if anybody wants to do anything extra with blockchain or with cryptocurrency, let us know and we can possibly do a part 2.